In this video, we're going to look at number 19 and 20 on your SlopeFields handout. And we're going to be looking at doing solution curves. So this very first one says is a calculator drawn slope field. So there are programs that can be done on your calculator. You don't need to know how to do that. But this is for dy dx equals x times y. And it's been done for you. And you're just asked to draw the solutions. And they already drew the first one for you, which is the curve that goes through 0, 1. And so let's just see what they did. They started right here at 0, 1, and basically here it's horizontal, and it goes out until it hits a part and says, oh, my new slope is like this, and then it hits this next part, my new slope is like this. It just keeps following the slopes along. And it, of course, this one kind of visualizes some that weren't even drawn, but what would happen in between. So let's try a different one. I'll go 0, 2 here, and we'll do it in red. So at 0, 2, we're going to be right here. We can see we're horizontal, and then it's going to curve up, and we're just going to kind of follow the slopes as it does. And then we've got one more, which is let's see, pick a different color. Where are my color options? There they are. So we'll go with a green this time. So for 0, -1, we're going to have this one, but we'll see after we go off the horizontal, we're hitting these slopes. And now, by the way, it's not that it has to be perfect. Same thing on the AP exam. Sometimes they'll draw these, but it basically has to generally follow the slope. So kind of the right shape. You'll notice mine wasn't drawn as well as theirs. Now, you might be looking at these and saying, oh, half of them are parabolas up and half are parabolas down, and they kind of look like that shape. But I do want you to know that this equation, which you'll learn how to undo later, does not actually give you parabolas. And I did put this into Desmos so you can kind of see what's happening. Let me get this fitting into the screen. There we go. And I'm going to just run you through, and these are the family of the curves. So you've got all of these curves. You actually get a horizontal line in between there, and the equation looks like this one right up here. All right, we're going to go to another one, which is number 20. And this one, our slope fields have all kinds of different solutions. So the first one they ask us to sketch is 1 through 0, 1. So right here, if I go to 0, 1, I can see my initial slope goes off like this slope, which I think is 1 here, and then it just goes steeper and steeper. And then I come in here and I can see I'm going to hit a minimum, and this linear one here is going to be an asymptote. So what I get here is a curve that is concave up. So it's a concave up curve, and it has a diagonal asymptote. Diagonal asymptote. So that's my green example. And then they asked me to do one through -3, 0. So we'll do that one in red. So I'm going to go here, 1, 2, 3. So here's -3, 0. And I can see that I've got pretty steep slopes here that are going to get steeper as I go down. And then over here, a little less steep, like, oops, probably more like that. So something like that. That's the general shape of it. And this, of course, is a concave down curve. All right, it doesn't have an asymptote at all. It goes up to infinity here and down to -infinity here. There's one more solution that I want to point out that they didn't do. If we did the solution through -1, 0, it would be this, and it would just literally go as a straight line here. So we have one solution, exactly one solution, which is the line y equals, let's see, that looks like it's a -x and -1. So it's the line y equals -x -1. So this particular differential equation gets some solutions that are concave up, some solutions that are concave down, and one solution that is linear.